On our last video, we talked about the corresponding angles postulate, the alternate interior angles theorem, the alternate exterior angles theorem, and the same side interior angles theorem. Today we're going to be talking about converse theorems for these parallel lines. Let's start by looking at a conditional statement. If it is snowing, then it is cold. This is true because to have it snow, it has to be cold outside. But the converse is a statement that is not always true. If it is cold, then it is snowing. So converses can be true, but they are not necessarily always true. Now, converse theorems for parallel lines work both ways. If two lines are parallel, then the corresponding angles are congruent. The converse of that is also true. If two lines cut by a transversal so that the corresponding angles are congruent, then these lines have to be parallel. So J would be parallel to K. The alternate angles theorem says if two lines are parallel, then the alternate interior angles will be congruent. So if two lines are cut by a transversal and the alternate interior angles are congruent, then these lines have to be parallel. So this works both ways. Converse of alternate exterior angles also works both ways. If lines are cut by a transversal so that the alternate exterior angles are congruent, then the lines have to be parallel. And this would be the converse. The converse of the same side interior angles theorem says if lines are cut by a transversal so that the consecutive interior angles are supplementary means they add to equal 180 degrees, then the lines have to be parallel. So if you know that the angles are congruent, then the lines are parallel. This would be the converse. Let's do a flow proof. A flow proof is a flow chart that proves something. So we're going to just fill in these boxes to figure out this flow proof. First statement is our reason, which is given. So we are going to write the given information in this box. Angle 3 is congruent to angle 6. So that is our given information. Those are alternate interior angles. Now we could, what we're trying to prove that these are parallel. Now we can't use the converse of the alternate angles theorem because that's what we're trying to use. But in most cases, you could just go to that they were proven once we prove this here. So let's start with the vertical angles theorem. I'm going to put an angle in there. Vertical angles theorem, angle 2 and angle 3 are congruent. So I'm going to put angle 2 is congruent to angle 3 because those are our vertical angles. Well, we are going to use the transitive property. We're going to say that 2 is congruent to 3 and 3 is congruent to 6, so 2 has to be congruent to angle 6. Angle 2 has to be congruent to angle 6 by that transitive property. It makes a train. 2 is congruent to 3 and 3 is congruent to 6, so 2 has to be congruent to 6. Now since we know that 2 is congruent to 6, we're going to use the converse of the corresponding angles postulate to prove that the alternate interior angles are congruent. So J must be parallel to K since 2 is congruent to 6. We're going to use the same sort of idea to prove the converse of the same side interior angles theorem. So let's do a two-column proof here. We're going to put our statements and our reasons on S and R for statements and reasons. We always write the given information first. Given, and the measure of angle 4 plus the measure of angle 6 equals 180 degrees. So we're talking about the angles, and so since we're talking measures, we're going to put equal. We're not going to put congruent there. Now, 4 plus 6 equals 180. I also know that 6 and 8 are on a straight line, and so the measure of angle 6 plus the measure of angle 8 has to equal 180 as well. And this would be because they are linear pairs. So we're going to say the linear pair postulate. Now we know that 4 plus 6 equals 180 and 6 plus 8 equals 180. So we can make a train. 4 plus 6 is 180 and 180 equals 6 plus 8. So we know that the measure of angle 4 plus the measure of angle 6 equals the measure of angle 6 plus the measure of angle 8. Now both of, and we will say that that is because of the transitive property. Now I'm noticing when I'm looking at this, I'm noticing both of these have a 6 on each side of the equal sign. If I get rid of that 6, just subtract 6 from both sides, I will have the measure of angle 4 equals the measure of angle 8. And that would be because I use subtraction property of equality. Now 4 and 6 are on the same side in the same place. They're both on the bottom right of these parallel lines. So that is the corresponding angles postulate, tells us that if the lines are parallel, the corresponding angles are congruent. But we're going to be using the converse. We're showing since the angles are congruent, the line has to be parallel. So J has to be parallel to K by the converse of the corresponding angles postulate. Now we're going to find the values of x for which L is parallel to M. So since these lines are parallel, the corresponding angles have to be congruent. So they will be equal to each other. The measure of the 56 plus 2x has to be equal to 7x plus 1. So we're going to minus 2x from both sides of the equal sign. 7x minus 2x gives us 5x. We're going to minus 1 from both sides at the same time, which gives us 5x equals 55. I divide by 5 on both sides of the equal sign, and x is going to equal 11. Now, this next one's a little bit trickier. Now, L is going to be congruent to M. So I know that 2x minus 10 would be equal to its corresponding part right here. Now, I don't know what that is, but I know that this angle is 120 degrees, and 120 degrees is on a straight line with this angle here. So I know that this angle here has to be 60 degrees. So this angle is corresponding to that, so that also is going to be 60 degrees. So I'm going to say 2x minus 10 has to equal 60. So I'm going to add 10 to both sides. 70 equals 2x. 2 times 35 is 70, so that's the same as dividing by 2. So x is going to be 35. Now, on this next one, we need to figure out which lines are parallel. So we're going to say that angle 5 is congruent to angle 4. These two are alternate exterior lines to P and Q. So if P and Q are here, here's our transversal. 5 and 4 would be alternate exterior angles. So P and Q would have to be the parallel lines. P is parallel to Q. Now on this next one, 6 and 10, this is the transversal, and J and K are our parallel line. These are the same side interior, which are supplementary and add to 180 degrees. So J would be parallel to K. Now looking at 3 and 8, 3 and 8 are vertical angles. All vertical angles are congruent. That does not have anything to do with parallel lines. So this is no lines are parallel. Okay, now number 8 is 2 and 10. Now if I look at angle 2 and angle 10, they will be corresponding angles. Here are my two parallel lines, here's my transversal, these are corresponding lines. So this would be showing J and K as the parallel lines. J is parallel to K. Now we also need to state which postulate we used. So if P and Q are our parallel lines, and I'm looking at angle 5 and angle 4, they are alternate exterior angles. So we are going to use the converse of the alternate exterior angles theorem. Now 6 and 10, they are same side interior angles. If those are supplementary, then the lines are parallel by the same side interior angle converse. Number 7, we don't need to write any theorem because we didn't use it. There are no lines that are necessarily parallel. On number 8, we're looking at 2 and 10. Those are corresponding angles, so that would be the converse of the corresponding angles postulate.